Hello friends, in this video I will show you how to configure encoder with Delta PLC. That is how we can interface the encoder with Delta PLC, how we can program the same, and how we can do wiring for the encoder and Delta PLC. Okay, let's start. Okay, so we have Delta PLC and Kubler encoder. Okay, the KIS 50 is the model number of our encoder, right? So whenever we have to wiring for the PLC and encoder, for in encoder side we have plus 24 volt supply and minus 24 volt supply to encoder. We need to give the supply to the encoder. Okay, so encoder should be the 24 volt. Okay, because PLC working voltage is a 24 volt, so we need 24 volt DC encoder. And so in at encoder side we have phase A and phase B. That is, these are the encoder output. Okay, means this A and B give pulses to the from encoder, and this is the encoder output. Okay, so on encoder manual you can see which are these cables for plus 24, minus 24, and A and B. Okay, so you need to connect this A to X0. X0 means X0 input of PLC. Okay, and B is to X1. Okay, so X1 is another input of PLC, and in for PLC input, that is SS, you need to give the 0 volt. Okay, so in this encoder we have the plus output from A and B. Okay, so that's why for in common input common I have given 0 volt to the PLC. Okay, suppose if you have encoder which gives the negative output, that is A bar and B bar, in that case you have to give here plus 24 volt to common to the input. Okay, so this is power supply to PLC plus 24 volt DC. Okay, so in this way we need to wiring up encoder and PLC. Okay, so another part, so this encoder is of 3600 ppr, means you can see in manual what is the ppr of your encoder. Okay, so ppr means pulse per revolution, means it gives 3600 pulses to PLC for one revolution. Okay, so if we want to convert these pulses to our or meter, whatever as per your application, so how we can calculate for the same? Okay, I will show you. Suppose for one rotation you have the travel distance is 10 mm, right? So you have 10 mm distance travel for one rotation, then it means for 3600 pulses we can consider 10 mm, right? Means for one revolution encoder gives us 3600 pulses, and it means 10 mm. So we can calculate based on this ppr and this 1 mm distance. We can calculate another things, like if we divide this 3600 with this distance, we can get the pulses for 1 mm. So here in this case we have 360 pulses for 1 mm, right? So in program now we will see how to convert this in mm. Okay, so first before going we will see this in ahead. Okay, so how we can calculate our actual mm based on the input pulses. Okay, this is the formula for the same, means input pulses divided by 360 means pulses for 1 mm. So we got the value in mm, actual travel distance. Okay, so here I have given the example. Suppose you have 5000 pulses at input, so divided by 360, it means 13.8 mm travel distance, right? So let's start the programming part. Okay, open WPL soft, so which is for Delta PLC programming. Okay, I will just close this project. Okay, create a new project, give the name, let's say encoder. encoder test. Select your PLC model number here. Okay, I have SE PLC, so I am selecting SE. Okay. Okay, now here in toolbar you can see here this is high speed counter option there. Okay, so you can over the cursor here, so one by one, then you can see here high speed counter. Just click on this high speed counter. Okay, you will have this pop-up window. So here 2-3 options here. So this is one phase input. It means whenever you have only one direction of, okay, means you are traveling just clockwise, you are not traveling back again. It means you have just one direction, that is clockwise. In this case you can use this one phase input. Okay, so in our case I am going to use one phase 2 input. Okay, one phase 2 inputs means whenever I will click rotate clockwise, okay, it gives x0, and I have connected another wire to the x1, right? So we have two inputs, x0 and x1. That's why I am taking one phase 2 inputs. So whenever I will rotate clockwise, it will add the pulses. Whenever I will rotate anti-clockwise, it will minus the pulses. Okay, so this is condition. Let's take here M1000. It means always on bit. Okay, set value, let's suppose take a maximum as possible as. Okay, these are the settings. I have connected x0, one encoder input to x0 and another one is to x1. Okay, so click on next. So these are the some instructions. If you want to use this instruction, you can use it or you can avoid it. Okay, so it is depend on your application. So suppose if you want sudden any action output, any turn on any output, then you can use these instructions. Okay, I am not going to use here, so just click on finish. Okay, let's save the program. Yeah, now let's download the program in PLC. Check the communication port. Yeah, so here some value is there. So first, if we will reset this counter, let's take LDM1 and reset CNT, sorry DCNT, sorry reset C 245. We have the counter number 245. Yeah. Let's download this. Right click, set on. Okay, now you can see it is 0. Let's take it, set off. Okay, so now you can see the incoming value of encoder is 0, right? So now I am rotating the encoder. Okay, I will rotate clockwise. Okay, you can see the value is incrementing. Okay, so I stop rotating, the value stop. I again started rotating, value get incrementing, right? So for one rotation we have 3600 value around. Okay, so I am almost I have done almost one rotation here. Yeah, okay, so again I will rotate. So now I will rotate anti-clockwise, so you can see the value will be decreased, so value is decrementing, right? Value is decreasing. I stop rotating, value is again I start clockwise, then value will increase. Again I start anti-clockwise, value will be decreasing. Okay, so and whenever you want to back it to the home, means suppose you want this as a home, then at home condition you need to just trigger on this bit, suppose set on, then this value will get to 0, turn off, then again it will start counting if I rotate the encoder. Okay, so suppose now this is the value C245 you have from encoder. So suppose you want to convert it in mm. So as I have shown recently in slide, so this is actually your calculation, right? So I will just divide this counter C245 with divided by 360, then I will have actual distance, travel distance. So let's write some code for that. First of all, we will move this C245 in one register, demove C245 to D100. Okay, so simply we have moved this value for this counter to this D100. Okay, let's convert this value D100 value in floating type, dfloat D100, and just save this value in D104. Okay, now just divide this value by 360. That is F360.32, and store the result in D108. Okay, yeah, let's download this program. Okay, let's monitor this value. Let's take here D108. D108, number of register 4. Okay, so 108, you can see here it is 2.869. so suppose reset this counter again. Okay, so now the value is, this is 0, right? So now I am rotating the encoder, you can see actual value. So now let's take 3600, almost for one rotation it will show 10 mm, right? You can see here this is almost 10 mm for one rotation, right? So for example, So for 5000 pulses it should be a 13.8 mm, right? So let's again rotate to the 5000. Yeah, you can see here it's almost 13.9, right? So in this way you can calculate from this encoder, you can convert your actual distance in mm and all, or you can program as per your requirement. Okay, thank you friends, thank you for watching this video. For more interesting video, please do subscribe to our channel.